In this video from the Cisco CCNA lab guide, the free download from Flackbox.com, I'll be working on the 16th lab, which is spanning tree configuration. And we'll get down here. And it says you discovered that switch ACC3 is the root bridge. So that was in the previous lab that we did. This is the root bridge. We discovered that in the spanning tree troubleshooting lab. And traffic is not taking the most direct path across the network. You'll correct the configuration in this lab. So it says configure the network so that traffic between the PCs, which are down here, and the internet up here, travels along the shortest available path. If a core distribution switch fails, traffic should fail over to the next shortest available path. Do not change any layer 3 up here configurations such as HSRP settings. So previously in the troubleshooting lab, this was the root bridge. So what was happening was traffic was going from, I believe, ACC4 to CD2, back down to ACC3 since it was the root bridge, then to CD1, then out. And that's obviously not the most direct path. And we can't change any HSRP settings here, but we need to make sure that spanning tree aligns with HSRP. So let's get started there. Let's look at our router and enable and show standby. And let's check that. We see that the active router is local, so R1 is the active router for HSRP. Preemption is enabled. Priority is 110. We're not allowed to change any settings here, but we need to work from there. So R1 is connected to CD1. So what we should do is, instead of ACC3 being the root bridge, we should make CD1 the root bridge. So let's go into CD1. Let's pull up the command line. Pull this up a little bit. All right. So we're going to go to enable, and we need to go to global configuration. We need to do spanning tree, VLAN. It was VLAN 10. And we want to do root primary. Yes, for CD1. And it did say we need to make sure that we have fails, traffic should fail over to the next shortest available path, so we should make this the failover. Let's go into CD2 and enable Conf T. And now we want to do spanning tree, VLAN 10, and we want it to be root secondary. So that's set up. So we should have CD1 as primary. This CD2 will be the failover. Now we need to verify the priority on CD1. So let's look at it right quick. So, and show spanning tree VLAN 10. So CD1. Okay. It says this bridge is the root, so we've made this the root. And its MAC address ends in 3902, so we'll remember that. Okay, so now let's look at CD2, and we want to go end, and we want to do the same thing. I'm going to do show spanning tree VLAN 10, and we remember 3902 was the MAC address for CD1, and we see it here. It's the root ID 3902. Its priority is 24,586 as compared to CD2, which is a 28,682. Okay, so that's good. Now let's compare the priority of CD2 also to these switches to make sure that it stays the secondary. So enable, or actually no, show spanning tree, VLAN 10. And so open this up a little bit. So ACC3, that switch has a priority of 32,778 compared to CD2's priority of 28,682. So the lower is better. So that's fine. And then let's compare it to ACC4, access 4, show, enable, show, spanning tree, VLAN 10, and it has 32,778 for its priority on access 4, and so CD2 does have better priority. So that's all correct. So now let's look at the path between the PCs and the internet. So we've changed from this being the root bridge to this being the root bridge. We've confirmed that this is the secondary. This will be the failover in case this goes down. And previously in the last lab, we remember traffic went from PC2 to ACC4 to CD2, back to ACC3 since it was the root bridge, then to CD1 and then out. And let's see if we don't have some improvement on that now. So let's go down to PC2, and we need to look at the, well, let's get the MAC address again first so we know what we're looking for. Show standby. And the virtual MAC address, this is the virtual IP, 10.10.10.1 right here, and we're looking for AC01 is the last part of the virtual MAC address. So AC01, we'll remember that. And let's go down to PC2. And from PC2, we want to clear the ARP right quick. ARP-D. And then we want to generate some traffic up to that virtual IP. So let's ping 10.10.1. Okay, that's good. Now let's start looking at the MAC address tables and see what route this is taking. So let's pull up ACC4 and let's do a show MAC address table. And we're looking for AC01. Remember that was the MAC address for router 1. So here it is. So access 4 switch now knows that router 1 is available out fast Ethernet 021. So it is out this one. Previously, in the last lab, remember it was going this direction. Now it's going the direct route. And then let's jump over to CD1 and make sure it's going. It sees the MAC address of AC01 out G01. So let's do that quickly. And we're going to do show MAC address table. And AC01 is out gig 01. It's out gig 01. So now the traffic is going from PC2 to ACC4 to CD1 to R1. And that is the direct path. That is what we want. So that looks good. So we've configured the network so traffic between the PCs and the internet travels along the shortest available path. If a core distribution switch fails, traffic should fail over to the next shortest available path. Okay, we have that set up. We didn't change any layer 3 configurations. So now to port Fasten Bpdu Guard configuration. It says a layer 2 loop cannot be formed on a port where a single end host is connected. So for example, you're not going to have a loop where you have a single end host connected right here. So disable spanning tree on these ports. It also says you are concerned that a user may introduce a loop into the network by adding additional switches or changing the cabling. Also, so in other words, if you have a user down here at PC2 and they bring a switch from home or from wherever and plug it in, all of a sudden, if you have what's called port fast set up on this, so that spanning tree is turned off, you are going to have potential issue. And it says you are also ensure that the ports where spanning tree is disabled, so like down here, will automatically shut down if a switch is detected on the other end of the link. So to do that, so basically what we have to do is it's saying disable spanning tree on the specific ports. So we'll use port fast on that. We also need to set up Bpdu Guard, which is what Bpdu Guard does. It's going to detect if a switch has been plugged in, and it'll shut down. It'll shut it down in case somebody does come in and plug in a switch. So let's go ahead and get that set up. So we know for ACC3, we can take care of F01. So let's go into that. And comp T, interface, fast Ethernet, 01. And on 01, we're going to do the port pass command. So it's spanning tree. And it's just port fast. That'll turn that off. And then spanning tree Bpdu Guard, and we want to enable that. So that's set up. So we have spanning tree off, plus we have Bpdu Guard enabled, so that if there's a problem. Okay, so that's ACC3. We also need to do ACC4 down to PC. So this is F01. So let's get into that. So comp T, move this out of the way. Interface, fast Ethernet. Oops, hitting cap locks. 01. That's the one we're going to work on, right? Yep. And for that, we're going to do spanning tree port fast. And we want to also do spanning tree Bpdu Guard and enable. Set that up. So that was that interface. Now we can do the same for CD1 up to the router and CD2 up to that router. So let's jump over to CD1, pull it up, and global configuration mode. CD1, we want to do interface, gigabit Ethernet 01. And we're going to do spanning tree port fast for that one. And we're also going to do spanning tree type Bpdu Guard enable. And that's going to be for CD1. Now we need to set up CD2. All right. And global configuration mode, that out of the way. We want interface gigabit Ethernet 01. And we're going to set up spanning tree port fast. And we're going to do spanning tree Bpdu Guard enable. Oop. Enable. Okay, so that should be done too. So we took care of it on this one, this connection, and this connection. And you are concerned that a user may introduce a loop in the network. Okay. Sure that the ports where spanning tree is disabled will automatically shut down if a switch is detected on the other side of the link. So we did that, and that looks like it's the end of the lab. That was spanning tree configuration. So they had it in a reverse order. Typically you do the configuration and then the troubleshooting, but with spanning tree, because the way it was set up, we did the troubleshooting first, and then we did the configuration afterwards to correct the problems. So that was lab 16, and I will see you in the next video.